So what did we study in the last class? The module 5, it's basically talks about the backtracking problem, correct? So we already know how the backtracking approach works to solve to get a solution for a given problem, right? And we also discussed about something called state space tree, correct? We are going to construct a tree, and based on which we are going to derive it. Even in backtracking, we are going to get the solution for all the sub problems, correct? So what is the difference here? It need not to be used only for the optimization problem. It can be used for other different categories of problems also. That was the difference between backtracking and the dynamic programming. And the other one you should remember over here is the backtracking is follows a depth first search, correct? Even we the backtracking follows a depth first search, correct? And we also know about bounding functions. Bounding functions, it's basically nothing but a constraints or a conditions based on which we are going to stop. Fine. So that is a bounding function, depth first search, DFS. Bounding, I mean, the backtracking follows a DFS with some bounding functions. Bounding functions is nothing but a conditions based on which we are going to tell whether this is a prominent end or not, correct? So all those things we have seen, and also we have seen n queen problem, correct? How to solve a n queen problem. We have considered a chessboard. We have seen n cross 4 cross 4 problem, right? 4 cross 4, or that is 4 queen problem. We have seen. We have also seen how to solve a problem. Okay, so the next topic under backtracking is finding a subset, finding a sum of the subsets. Okay, so the next problem here is sum of subset problem. Okay, sum of subset problem is the next topic over here. Okay, so what is the problem here is the problem statement, it goes something like this. Just a second. Okay, the problem statement of sum of subproblem the problem statement for sum of subsets problem is, let us consider we have given a set of n positive integers. Find set of n positive integers is given, so that is represented as s is equal to s1, s2 till sn. Okay, so this is a set of subproblems. Okay, am I are the screen is visible? Is the screen is visible? I hope whatever I am writing, it is visible for you. Fine. Okay. So what is the what is the problem statement of sum of subset is s is equal to that is a set s is equal to set of n positive integers. So all those s1, s2, sn are the set of positive integers. So what we need to find here, we need to find a subset. Okay, we need to find a subset whose sum is equal to a given positive integer. I will repeat. Okay, the problem statement of a sum of subset problem is what? Given a set of n positive integers, we need to find a subset whose sum is equal to a given positive integer d. Okay, for example, the positive integer d is given. We need to find a subset, say for example s1 plus s2 plus s3 should be equal to d. Okay, we need to find a subset from the given set of n positive integer such that the sum of the subset should be equal to a given positive integer d. Clear? So what and all is given? A set of positive integers is given and a positive integer d is given. Okay, subset of these given set, the sum of that subset should be equal to d. Am I clear? For example, say 1, 2, 3 and 4 is a subset, is a set which is given. Now d is equal to 4. Am I clear? D is equal to 4. So in such case, So I need to find a subset for this given set. Say for example 1 comma 2, it's not possible. 1 2 3, it's not possible, correct? So this subset will not give me the solution. Then go for 2 3, will not give me the solution. Likewise, you need to derive various subsets such that the elements of all the subsets should be equal to 4. So what is a possible one here? 1 comma 3 is possible, 4 is possible, correct? So is there any other possibilities? 3 plus 1, yeah, that is also same. So that's how it is possible. So what should be the solution? The solution can be represented in terms of 0 or 1. Okay, if it is selected, then write 1. If it is not selected, then write 0. Okay, so what is the first possible solution? 0 0 0 comma 1, correct? So this is one solution. Next solution is 0 sorry 1 0 1 and 0. This is another possibility, correct? So there are two solutions for the given problem, that is 1 2 3 4. So this is a given problem where you need to identify the subset such that whose sum should be equal to a given positive integer, that is D. Am I clear with the problem statement? Is the problem statement is clear? Okay. I hope the problem statement is clear for you all. Okay. Let us take one example and start solving how to get the how to solve this approach using backtracking. Fine. So I hope you remember what is state space tree. State space tree is nothing but a solution tree, correct, for a backtracking problem where it follows a DFS, data, that is depth first search, correct? So let us take an example over here. Okay, I will take the sum of subset A is equal to, okay, so A is equal to 3 5 6 and 7. So this is the sum of subset, the set which is given here, which is having a set of all positive integers. Am I clear now? So all positive integers is given. Next, the another integer which is given D. D is nothing but sum of subset should be equal to D, that is 15 here in this example. If I ask you to derive this, write this manually, how will you do? Just add, perform some combinations of such various positive integers, then get the derivatives, then get the solutions. All those things you will do. Or if I ask you to draw some tree for this and then get me the solution, usually it will, what will happen here is, so usually what will happen, you will first take 3, then check whether this is possible for 5, then check for 6, then check for 7, addition of 6 7, all those things you're going to check. Then if it is not possible, again do for next thing. So usually if there are 4 integers, then 2 power n tree, what you can say, n height of a tree is required. Okay, so these solutions can be see this what you can say height. So this 2 here, again 1 2, like this, correct? So 1 2, so what is the depth of height of a tree here? It is 4. So if you see here, it is 8. So 2 power n is required here. 2 power n minus 1 n should be by n minus, okay, it is 2 power n, correct? uh, so that many that many nodes is required here. So in order to avoid all such things, what we are going to do here is what we are going to do over here is we are going to use a backtracking problem. Okay, so as I already told, let us assume a given set. So the solution, the question here is 3 5 6 and 7. Fine. So 3 5 6 and 7 is a given set. And what is the value of D? D is 15. Okay, so now what shall I do over here is the state space tree. Okay, I will start with something like this. Initially, what is the first step here? The first step, I will start with an empty set. Okay, I will start with the empty set. So the the total value, or the empty set value, is nothing but 0. Okay, 0 comma, what is the addition of all these? You can also call this as a weights. Okay, what is the total weight of a given set? If you count this, it is nothing but 21. So 3 plus 5 plus 6 plus 7 is nothing but 21. Correct? So 0, 21. What is this 0? What are the elements which we have selected right now? The numbers which you have selected from the given set. Right now it is an empty set, so it is 0. What is the total cost left out? It is 21. 21, how did we get? It is the addition of all the elements in the given set. So this is the first step. So now what shall we do? If you remember the previous class, the NQueen problem, even there we did, right? Either select or not select or something like this. Let me start with the first element in the given set. Okay, I will represent it with x1. So x1 is equal to 1. 1 represents I have selected that particular element from the given set. If x is equal to 1, fine. If x is equal to 1, what will be the set will become now the total amount, weight will become 3, correct? Because the first element number is 3. So 3 plus 0 is 3. What is the remaining? 21 is a total weight. What is the remaining? Remaining is nothing but 21 minus 3. 21 minus 3 is nothing but 18, I guess, right? So 18. Correct? So 21 minus 3 is 18. So with this implies what? X1 is if we have selected the first element. Correct? So now what? See, 3 is less than 15, so I can add some more elements until. And one more thing you should remember, it should not be less than 15. It should always, the sum should always be equal to 15. It should be equal, exactly equal. It should not be less than 15 also. That is also not accepted. That you should remember. Okay. So x1 is equal to 1. Then select the second element. So second element, I will represent it with x2. For selection, I will consider it as 1. Okay. So now what is the second element's weight? It is 5. So 5 plus previous element weight is 3. 5 plus 3 will become 8. Now 18 minus 5. Okay, 18, which means I have selected these two. What is the remaining amount? What is the remaining amount? It is 6 plus remaining weight. It is 6 plus 7. 6 plus 7 is nothing but 13. Correct? Am I correct till now? Okay, which means I have selected the first, I have selected the second element. So 18 I got, which is less than 15. So I can go further also. So go for the next element, 8 plus 6. Next, that is select x3, that is element 3. I am selecting it. So 8 plus 6 will give you what? 8 plus 6 will give you 14. Correct? Okay. Due to network problem, what has got stuck? Okay, let me start from the beginning. Sorry for the inconvenience. So I'll just go through all these ones. So 3, 5, 6, and 7, and D we know it is what is it? 15. Correct. So I was talking about this. So initially it was 0, 21. Then the next element is selecting the one, which is the x1 is equal to 1. So this will become 18. That is the remaining element. If I select x2 is equal to 1, x2 is equal to 1. So adding the element x1 and x2, you will get 8. So 8 comma 13. Now I will select x3 is equal to 1. If I select x3 is equal to 1, what is the value which you will get? 14 comma 7. Correct. So 14 is still less than 15. So I can further continue. So selecting x4 is equal to 1. So if I do over here, if you check it out, x4 is equal to 1, x4 is 7. 7 plus 41 will leads to the value 21, comma. Is there any other element which is left out? That is 0. Correct. Are you all understanding? Are you all getting the point? Okay. Fine. So 21 comma 0. How did you get 21? 21 is because we have selected all the elements. If you check here, x1 is equal to 1, x2 is equal to 1, x3 is equal to 1, x4 is equal to 1. Correct. So all the elements are equal to 1. So 21. But if you see the addition of which this implies, I am taking all the elements in the given set. Okay, but the final result which I got is 21, which is not equal to 15. So I should have something called like bounding function to, or a condition. Bounding function is nothing but a condition in order to, this is not a promising node, correct? This is not a promising node, so I should not select this. Am I clear? So what is a bound? So this is a bounding function we are applying over here, and this is not condition, correct one. So what is a bounding function? The bounding function, bounding function over here is summation I is equal to y 1 to k. Okay. So wi and xi plus, that is the next element. So k plus 1. This should be less than or equal to d. Okay. So this is the bounding condition. So what is this bounding condition says over here is, okay, wi plus xi is nothing but the weight. This is a weight and it's the element and its weight, correct? The element and its weight. So here what this says is the sum of the, this is nothing but the sum of the weights included so far. This is the sum of the 21 is the sum of the weights included so far plus the sum of the next weight. If it is less, this should be less than or equal to d, correct? This should be, this 21 is not less than or equal to d, it's not less than. So which means this is not meeting the bounding function, so I'm not going to select this because this is not a promising one. Okay, so now you know backtracking, obviously we need to go back. If this is not the optimal solution, we need to go back. So go back here. Now according to this x4 I have selected, now make it not selected. So x4 is equal to 0. Are you getting this point? Till here I hope this is clear. Okay, so since this is not a promising solution, I need to go back because it is a backtracking problem. You know how backtracking problem works. Go back now, check for the another alternative. X4 we have selected. Now we are not selecting this, so that is why represented with 0. If you are not selected x4, the sum will become 14 only, correct? And next after x4, is there any other element? No, only x4 is there, no other element. So I will make it as 0, correct? Now you check, if you check it out, 14 is less than 15. So this condition is not fine. I will write one more bounding condition, right? So what is this bounding condition? Summation I is equal to 1 to k. That is, this is nothing but the elements which is added so far plus the summation. Okay, that is the elements, the next set of elements. So summation n is equal to 1 to n wi should be less than d. Should be greater than d. Am I clear with this? So what is this condition? This is the element and the set of the remaining elements, I don't have anything. So 14 plus 0 over here, 14 plus 0 should be greater than 15. But this condition is not true. 14 is less than here. So even this is not a promising node. I'm not going to select this. Are you clear? So you remember these two bounding functions. Okay, the a node should satisfy, if the node satisfies this, okay, which means yes, this is the optimal solution. Otherwise this is not a optimal solution. This is not a promising node. Okay, this is not a promising node. Again you should go back till here. Okay, so x3 I have selected, so I will now make it as 0 because we need not to select x3 now. So what will I do now if x3 is equal to 0? Okay, so which this implies what? I have selected only first two elements, x3 I am neglecting, so it will become 8. If I don't select x3, what is the, if I don't select x3, what is the remaining one? It is 7. So 8 comma 7, correct? So 8 comma 7. Are you getting this point? So 8, how did we get? Which implies that first I am not selecting 8, I am not selecting the third element. I have selected the first two elements. First two elements sum is what? 8 comma. What is the next sum, next element, next remaining elements? It is 7. So 7 I have written. So 8 is less than 15. The condition is not true. It should be equal to 15. 8 is less than 15, which means I can add some more elements. So what shall I do? I will include x4 is equal to 1. Select x4, I mean select the fourth element. 8 plus fourth element value is 7. Weight is 7. So 8 plus 7 will become 15. Okay. Any other elements after 4? No, it is 0. Correct? So 15 is 15 comma 0. Now add these two, 15 comma 0, you will get 15. Yes, 15, I mean it is equal. This condition is satisfied, correct? So if you check it out here, the first bounding function is satisfied. That is the next element is 0. 15 is the sum of elements so far. 15 is the sum of the elements so far. and the next element value is nothing is there in the next element, so I will represent it with 0. 15 plus 0 is 15. Yes, 15 is less than or equal to, condition is equal to is also there, so 15 is equal to 15. So this condition is satisfied. This is the optimal solution. So that is the optimal solution. Am I clear here? So that was the optimal solution. So the solution here, whatever which we have given here, is the optimal solution. So just remember, this is the optimal solution. Now I will represent here. So this is representing 1, 2, 3, 4, the elements. Clear? So if you go back, which and all we have selected? X4 we have selected. Then go back. X3 is not selected, so represent it with 0. Then again go back. X1 we have selected, so 1. Again go back, X1 is selected. So this is one of the solutions. So select 1, 2 and 4. So 1 is what? 3. 2 is what? Okay. So 1 is what? 3. 2 is what? 5. And 4 is what? 7. Addition of this is 15. Addition of this is 15, which means our solution is correct, whatever we got here. So this is the first solution. So do we need to stop here? We need not to stop here, because we already know there can be n number of possible solutions. So there are n number of possible solutions. I need not to stop here. Again go back. Correct? So this is one possible solution. Okay, fine. Again go back for the next alternative. So I will make x4 is equal to 0. If I make x4 is equal to 0, what is the value which I got? 8. I will leave it as it is. After x4, no other element, so it will become 0. Clear? So 8 is less than 15. So according to this condition, this is not satisfied. Correct? So this is not fine. Am I clear? So this is not, this was not fine, this was not fine, this was fine, but this was fine. You can select this is the optimal solution. Am I clear till now? Any doubts? If you have any doubts, need not, if you have any doubts at this point, you raise your, just ask me or ping me in the chat so that I will reply. If you know until here, the remaining steps are almost similar. Okay. So we have done with this. So again, go back to the next solution. Okay, so go back to the next solution. This is, we have done with this x3. So we have done x1 is equal to 0. Now make x2 is equal to 0. Okay, so now make x2 is equal to 0. What is the value which you got for x2 is equal to 0? You will get 3 only, which means I have selected only first element. What is the remaining? 6 plus 7. 6 plus 7 is 13, if I'm right. Okay, 6 plus 7 is 13. Yes, it is correct. So after this, make x3 is equal to 1 now, which indicates select x3. X3 is if x3 is equal to 1, 6, what is the value of x3? It is 6. So 6 plus 3 is 9. 9 comma remaining is 7. Correct. So again go back, because 9 is not equal to 15. Again go back, select x4. So x4 is equal to 1. Correct. So x4 is, if x4 is equal to 1, what is the solution? 9 plus 7. 9 plus 7 will be 16. 16 comma 0. This is not correct one. So go for the next alternative. X4 is equal to 0. If x4 is equal to 0, 9, it will be 9 only instead of 7, because no other elements after this. So 0. 9 is also not equal to 15. So stop there. Again go back. X3 is equal to 0 now. If x3 is equal to 0, which means not selecting x3, what is the value which you get? 3 comma 7, right? So again go back with x4 is equal to 1 and something like this. Correct. So if this is also not possible, go back and do this. Okay, so next possible solution over here is x1 is equal to 0, because we have done with selecting x1. Start with not selecting x1 is equal to 0. If you're not selecting it with x1, okay, if you're not selecting these with x1, what is the possible value over here? It is 0 comma 18. 0 comma 18 is not possible. Again go back. So it will be something like this, repeated. Correct. So I hope this is clear for you. So after solving completely, you will get only one solution, no other alternative. So the solution for this is 1, 1, 0 and 1. Okay, 1, 1, 0 and 1. Am I clear now? So this is the solution which you get. Okay, so let me write the solution for this problem, the complete solution for this problem. Okay, so I will just erase this. I will write this. Meanwhile, you also copy down if you have book and notes and book pen with you all. So just copy down and just try to solve along with me. So D is equal to 15. I think this board is not enough sufficient. So 0, 21 was the first solution. X1 is equal to 1. I hope I'll just check whether I have a solution always. Let me write only. Okay, so 3, 18, and this is what? This is 8, 13. This is 14, 7, I guess, right? So 7, and this is 21, 0. So which this indicates x4 is equal to 1, x3 is equal to 1, x2 is equal to 1. So the next solution is not selecting x2, I am making it as 0. So you will get 3, 13. So x3 is equal to 1, x3 is equal to 0. You will get 9, 7 over here. You will get 3, 7 here. You will get 16, 0, because we know it is if x4 is equal to 1, if x4 is equal to 0, you will get 9, 0. So this is not possible. This is also not possible, not possible. So here again you have two possibilities. So x4 is equal to 1, x4 is equal to 0. So what is the solution which you get here? 10, 0, because 3 plus 7 is 10. Here you will get around if x4 is equal to 1, you will get 10. Here you will get 3. Here you will get 10, 0. This is also not possible because 10 and 3 is not equal to 15. Correct. So this is x2 is not equal to 0. Again, you have one more solution which I already showed you, right? I'll just show you this. X1 is equal to 0. If x1 is equal to 0, initial condition is 0. I didn't include anything, so it will be 0 only. Except 3, the remaining solution, I mean, sum is 18. So now select x2 is equal to 1. If I select x2 is equal to 1, sum is 5 now, remaining is 13. Now select x3 is equal to 1. If x3 is equal to 1, 5 plus 6 is what? 11, remaining is 7. Next select x4 is equal to 1. x4 is equal to 1 means 11 plus 7, it is 18. 18, the remaining is 0. 18 is also not equal. So just go for the left one now. Then if it is not possible, again backtrack. So x4 is equal to 0 now. If x4 is equal to 0, 11, 0, even this is also not equal. Again go back. We know this is how backtracking works, correct? So x3 is equal to 0. So this is such a huge solution, okay? So please try on your own first. Okay, so x3 is equal to 0. I will get around 5, 7. Similar way, go for x4 is equal to 0 and x4 is equal to 1. You will get some solutions. Again here, so we have done with x2 is equal to 1, selecting x2. Now select x2 is equal to 1. This only solution we got for this problem is selecting 1, 2 and 4th element. This is the solution, correct? So that is nothing but 3 plus 5 plus 7, you will get the exact number 15. Otherwise also you check it out, other possibilities is not at all possible, correct? So this is the solution. So try to solve this state space problem usually. Okay, this is there is advantage over here in the backtracking. Otherwise, what you are supposed to do, you need to go back. So by looking at the condition only, you can just stop over here, correct? Need not to go over here. This is, see, whatever we have written here with this box, I have written only for your understanding purpose, correct? For your understanding purpose. What you can do over here is clear. Okay. What you can do over here is, I'll just show you. So this step, you are not supposed to go only, okay? So according to the bounding condition, if you add here, okay, if you add 14 plus, if you add 14 plus 7, which will give you 21, need not to go for the next step. So I add how many height here? 5 heights I add, right? So 0, 1, 2, 3, and fourth one. This in the row node, whatever I wrote, need not to write that respective node, because adding this according to the bounding condition, adding 14 and 7 itself will give you 21. 21 is actually greater than 15. I need not to proceed. I can stop over here. Okay. For for understanding purpose, I have written this 21 and 0. Need not to go there. Just check with this 14 comma 7 addition every time. Okay, every time keep checking. So if this is check for the conditions. If it is okay, then stop there only. Need not to proceed further. Okay. So even you can check over here is 18 plus 13. 18 plus 13 it will give you how much? 18 plus 13 will give you more than 15. So I can stop over here. Need not to go for the further procedures. Am I clear? So that is how the backtracking problem will work. Here only, in the initial step only, you can identify whether you're going to derive at the solution or not. Correct. Am I clear? So until, I mean, before going further, so just remember the backtracking. So, I mean, the bounding functions over here, and you can solve this. So this is an example problem. Okay, for backtracking. I hope, I mean, I hope you understood what is sum of subset problem. If any doubts, you let us know. So we will discuss in the next class also. This is all about today's class.